To our third remote lesson. Today we're going to be talking about two things. One of them is a tangent line and one is a secant line. If you're having flashbacks to Algebra 2, don't worry about it. We won't be talking about the graphs of tangent or secant. Let's take a look. So our aim today is what are the properties of tangent lines. We've talked about tangent maybe before, but today we're going to actually put a name to it. And our opening exercise is a line and a circle. Well, they can intersect in three different ways. They can first not intersect at all. That line doesn't hit the circle. It can intersect in just one place, kind of like it's balancing on the circle. Or it can go ahead and intersect in two places. This, when the line intersects the circle in one place, this is called a tangent line. This, where the line intersects in two places, that's called a secant line. You may have heard these terms before. Don't freak out if you're remembering trig. Now, the cool thing with a tangent line is it has an additional property. If we were to draw in a radius here going from the center to where it touches the tangent line, that's always going to be at a right angle. Every single time. So, no matter what, tangent lines always make right angles to a radius. So let's try an example with a tangent line. Your circle doesn't have to be this big, but it would be a good idea to draw it in, so why don't you pause and draw it. Okay, this is a 134-degree angle. This is the center of our circle. This is the tangent line. We're trying to find the value of x. Now, we can do this with a lot of the stuff which we've already seen with circles. We know that line segment AB and AC are radii. So that means that these two have to be the same. Now, we can use that fact to help us, because if this is 134 and triangle ABC is isosceles, well, I just do 180 minus 134, and that's going to give me 46. Well, I do 46 over 2, that's going to give me 23. So this is a 23-degree angle, and that is a 23-degree angle. Now, here's where the tangent line comes in. We know that this whole thing from the radius to this point has to be a right angle. It's probably the largest right angle I've ever drawn. So that means that this x just has to be 90 minus 23. Well, that's just going to be 67 degrees. So there, we found a missing angle by just using what we know about the tangent line and what we already know about circles. So you just saw about tangent lines. Now we're going to take tangent lines and combine them with secant lines. It's going to look like a lot. I promise that this is definitely one of those things where it's not nearly as difficult as it seems. So now I want to talk about what happens when tangent lines and secant lines intersect. And I have three examples here, where two tangent lines intersect outside the circle, where two secant lines intersect outside the circle, and where a secant line and a tangent line intersect outside the circle. In each example, we're going to try to find x. Now you might be thinking at this point in the lesson, oh man, this is where it went from kind of easy to oh my god, hard. Turns out, all of these use the same formula. It's just the measure of the big arc minus the measure of the small arc divided by 2. All three of these use that exact same formula. You might be wondering, well, how do I know which one is my big arc and which one is my small arc? Well, the nice thing is, you can look at your diagram. Here, this is our small arc. Here, this is our small arc. And here, this is our small arc. Well, here, this is our big arc. This is our big arc. And this is our big arc. So no matter what, if you have any diagram that has two lines from a circle intersecting outside the circle, you're going to use this formula every single time. And suppose you make a mistake and just say like, oh, I put the small one first and the big one second. You'll get a negative answer, and then just make sure your final answer is positive. Remember, angles can't be negative. And that's it. So let's try an example. If we were going to do this one, and this was a 130 degree, and this one was a 70 degree, well, this would just be 130 minus 70 over 2. So that's going to be 60 over 2, so 30. Let's do this one. If this was a 20 degree and this was a 40 degree, well, this one is just going to be 40 minus 20 over 2, so that's going to be 20 over 2, so that's going to be 10. Let's give this one a shot. If this one was 30 degrees and this one was 80 degrees, well, this would just be 80 minus 30 over 2. That would just be 50 over 2, so this would just be 25. That's all there is to it. Okay, so you just saw a bunch of examples where we're talking about the angles outside. Now let's talk about the angles inside. Again, really similar to what we've seen. So last big idea for today, we're trying to find the measure of this angle, and all I'm going to give you is the measure of this arc and this second arc. This is really similar to the previous one because it's just going to be the measure of the big arc plus the measure of the small arc, all divided by 2. A nice way to remember the difference between this and the one we just saw, these two cross like a plus sign, so there's a plus sign. Let's take a look. So if the pink one was going to be a 60 degree arc, and our blue one was going to be a 50 degree arc, then all we do to figure out x is say, well, 60 plus 50 over 2. Well, that's going to be 110 over 2. That's going to be 55, and that would be the measure of x. You might be asking, but wait a second, that's x. What about this one? Well, this would also be x because these two are vertical angles. And if you ever wanted to find this, well, this would just be 180 minus x. Cool, so you just saw how to find angles inside circles and outside circles using tangent lines, secant lines, and good old-fashioned chords. Head on over to Delta Math, give it a shot. Remember, you just need to get 5 right in each section, there's no penalty, and if you have any difficulty, check out the additional resources I posted below. Have a good one, folks.